Consider the lighthouse. To sailors, the lighthouse is a sign of welcome. Here is the sheltering cove and safe harbor. But with the welcome comes a warning. Beware, or you may founder on the rocks. Climate science is a 21st century lighthouse. Its findings bring welcome ways for us to live safer, healthier, and more abundant lives. This welcome information, however, comes with grave consequences if we fail to heed the warnings. This is When People Lead, where we celebrate leaders who work every day to make the world a better place. I'm Jeff Rollet. Our leaders today devoted their careers to the study of the Earth's land, ocean, and atmospheric environments, and the interconnections that impact all of us every day. They are Art Miller and Ralph Keeling of the Scripps Institute of Oceanography in San Diego. Take it away, Art.
Hi, Jeff. I'm Dr. Art Miller of the Scripps Institute of Oceanography of the University of California, San Diego in La Jolla, California. I'm a climate scientist, oceanographer, and I also work with biologists to help them understand the marine ecosystem response to physical forcing. What I am happy to do is just to share stories of my life and how they relate to the questions that you're planning to answer.
And full disclosure, Art is my brother-in-law. And so, Ralph, how do you feel? And tell us who you are.
So I'm Ralph Keeling. Like Art, I'm at the Scripps Institute of Oceanography at UC San Diego. I also work on topics related to climate. I guess in training, I'm more of a geochemist, although did a lot of physics. So I ended up in the field very close to my father. He was the pioneer measuring the buildup of carbon dioxide in the atmosphere. The curve, Keeling curve, is some of the audience may have heard of it. It's this rising curve of carbon dioxide. That's his curve that I have continued. I've also done measurements of similar compounds like oxygen in the atmosphere. All of this to try to track the big picture of what's happening with carbon dioxide and the human perturbation.
So let's start with the history of the Keeling curve, Ralph. It's been going on for more than 50 years. It is something that science around the world has used as an indicator or as a trend in the atmospheric buildup of carbon dioxide. And why does carbon dioxide matter?
Well, carbon dioxide has special properties. It's a greenhouse gas. It's the most abundant non-condensable greenhouse gas in the atmosphere, water vapor also being a greenhouse gas, but its abundance is controlled by the climate system, whereas the carbon dioxide has been being controlled by external factors like human emissions. So it's got very important properties that affects the climate. And the Keeling curve was the achievement of my father's showing, in the early years anyway, this buildup. So it put the topic of modern climate change really to the public attention and to the attention of other scientists, and paved the way for the establishment of a research agenda and a community that's focused on trying to understand this problem. And today I'd say its importance is partly symbolic, and you look at it and you say, okay, we still have a problem because it's still going up. But it's also relevant for understanding just how fast it's changing and what we could do about it. My hope would be that at some point with reductions in emissions, we'd see the curve start to bend. And so the curve could also at that point become a symbol, not just of warning we have a problem, but that we're starting to get control of it.
Yes. Art, how do you use that curve in connecting CO2 in the atmosphere, parts per million in the atmosphere, to the occurrence of more severe drought and flood and hurricanes, tornadoes, all of the other atmospheric weather-related issues?
That's a really good question, and it would require, probably an hour or two of explanations, but I'll do it in a simple way. So one of the key features of carbon dioxide is that it traps more heat than it would normally. In fact, if we didn't have carbon dioxide and other greenhouse gases, our temperature on the Earth would be much, much colder than it is now. So in the stable environment that we sort of inherited after the ice age, things are such that we have a nice, comfortable planet that gets cold in the winter and warm in the summer, and it's a hospitable place in many ways. But with the extra CO2 being put into the system, more heat is able to be trapped through radiative processes that, again, would take some time to fully explain. Because the air has more heat, the air is actually able to hold more moisture. So that helps to explain why you can expect what we call an enhanced hydrological cycle. The atmosphere is able to evaporate more and hold more hold more moisture. Say, for instance, taking moisture from the oceans and moving it over land and dumping it so it can rain more. But if the atmosphere happens to be dry in places over land, it can also absorb more heat from the land, so it can take away soil moisture and things like that, and also melt snow and things like that. So over time, you get an increase in the possibility for strong rainfall events, and also an increase in the probability of strong drought events for the very same reason. So that sort of ties back into your question of why CO2 is important.
And Ralph, how do you address those considerations in a way that can help increase the body of knowledge so that acceptance can occur, rather than set up this polarization that we're feeling about climate change?
An important point is that the extraordinary warming we are experiencing now, and there's no doubt that we are in a period of extraordinary warming relative to the last thousands of years, really, really extraordinary warming. That was predicted based on very simple reasoning before it happened. We could see it coming. And so already in the 60s, there were pretty good, and even before that, 50s, in a way going all the way back to the Svante Arrhenius in about the 1890s, making a forecast of what might happen if we continued to burn fossil fuels. So it looked inevitable then, and it happened. And so it's not that the theory was cooked up to explain the warming. The theory was there, and then it was confirmed by the warming. Incredible ability, science achievement showing that this was going to unfold. So, I mean, that's one thing. You can also just appreciate just how weird the climate is today, just by looking around. Forests are dying in places they lived for thousands of years. They're expanding into the Arctic. There's bare ground that had ice on it for thousands and thousands of years. It's now being exposed by glacial melt. Sea levels rising at unprecedented levels. This decade is warmer than the last decade, which was warmer than the decade before that, and so forth. When did we have that happening before? No time in human history that we can point to. We are in extraordinary times. So people just need to wake up that big things are happening, and we basically understand why.
Well, I can recall just in my lifetime, the hole in the ozone with the CFC issues, acid rain, and those are more localized events, I guess, where people realized, oh, we're killing ourselves, and now we're doing it in a more dispersed way, I guess, is what I see. For the last 40 years, I've lived in a desert climate and a high desert environment, and I've watched the snowpack disappear. I've watched drought conditions continue rather than cycle. The Earth is resilient, but the 8 billion or so humans on the Earth are not so much. And so what kinds of adaptations or what kinds of actions, I don't want to get into a prescription, but I want to say what kinds of adaptations are we going to have to look forward to in order to adapt to where we are right now, the way the climate.
When you think about sea level rise, you think about, well, don't build when you're really close to the sea level, because in 30 to 50 years, it could be a meter higher in sea level. So, strategizing and planning for the future is important. This is being taken into account by many communities that live in coastal areas around the U.S. and around the world, in fact. Military facilities that are near sea level are having to deal with this, even though they're being told from above that they shouldn't have to worry about it, but they have to anyway. I'm just going to stop there because I think Ralph might have better answers to this type of a question.
That's fine. Yeah.
Many societies and people and individuals have a livelihood that depends on the landscape, depends on the relationship to rivers and sea, the adjacent ocean and so forth, that are now under threat. And it's very thresholdy. So you can cope and you can cope and you can cope until some point you can't cope anymore. One of the key things about this problem is that once you realize you can't cope anymore, it's likely to be getting worse faster than ever. So it's going to be very hard to decide what you actually do at that point. And the solution, among other things, is just to get control of the pace of change by reducing fossil fuel emissions. So I want to make that point. What do we need to do as a society, as a humanity as a whole? We need to reduce our dependence on fossil fuels so that we can bring the emissions down. How do you do that in a political context where energy is so important for well-being? It's not easy, but embrace the energy transition because renewables are fun and they're cheap. And so let's have a party with renewables. That's part of it.
And embracing the renewable energy transition is a lot of what we're going to be talking about in this podcast. I have a background in some of that, and I know a lot of other people who are working on that right now. There's very many different ways to do that. Are there some things we can do that everyday people can embrace without constricting them or scaring them or making them worry? I fully believe that low-lying areas are going to need to address that issue. That's one thing. How do we adapt? Are there adaptable solutions that we can look at that people can start right now without creating a huge hiccup in the system?
Who do we want to have as a policymaker, right? That's the question that people have to ask themselves. Do you want to have policymakers that are trying to address the problem in constructive ways to really make life better for people? Or do you want to have politicians that stick their head in the ground and say, the problem doesn't exist. We're going to keep just doing business as usual, live the lifestyle that we lived 50, 70 years ago, driving our cars, doing whatever we want and not even thinking about it. So I think that's the thing that, people have to elect representatives, senators, and governors and presidents who actually recognize the problem and are willing to set policy to do something positive for the society in the context of climate change. That's inevitable now. In fact, we're living the first part of the nightmare right now.
So how do you translate your research into action for people to take? Is it in the form of recommendations, white papers, whatever? Is it something that that you can, there are conferences that share this information. There's the COP exercise that we go through where people present new ideas and new ways to go. Is that the only avenue that we can go, or are there more direct ways where what you guys do every day can be translated to action?
So my own focus is on that part of this community. And I appreciate very much the question about what to do about it, but I need to start with a caveat that that's mostly not what I work on. And I'm not apologetic about it because society needs people like me. And here's the other rub is that people say, well, the bad news doesn't motivate. We have to come up with good news. But I'm sorry. The news is grim. And I'm not going to put a silver lining on it just so that it can help policy forward. Our role as scientists is to be, just unfettered as much as we can, unfettered purveyors of knowledge and facts. And so if we stick to that mantra, Our role is not to put silver linings on the science; it's just to convey the science. And I hate to say it, but we are in a bad place, and we're moving into worse ground faster than ever. That's where we are right now. And as much as humanity has taken measures to reduce the problem, we haven't turned any major corner yet, except in attitudes of people, and that has to translate eventually into larger actions. And how do we get there? It's dicey because different people are afraid of different things going forward, and climate change is not the only thing that scares people. People are scared about other things, and a lot of fear is a big motivator, and it certainly has been in the last administration or current. So another twist on this, yes, to put it in perspective, this is an international problem, right? So the U.S. is now, I think, less than 15% of global carbon dioxide emissions. We own a much bigger share of cumulative emissions in the sense that we've produced much more than 15% of the problem today, probably more like half. But we're not what's moving us into bad territory fast anymore. It's the rest of the world and us together. So the solutions have to be international if they're going to actually have teeth and get things done. So how the international community works together to recognize the problem and work on it is super important. And I guess what's happened in the last year or so under this administration is very discouraging from that standpoint, because we're disengaging with the kind of international conversations that are going to be essential for moving this forward. So that's really, what can individuals do? You can't do a hell of a lot. Individuals can't make a heck of a lot of difference without support at really the level of governments and international cooperation. Technology waves can come through and make a big difference. So that's the easiest ground is to say, okay, we have new technologies, let's go with that. And that's why I emphasize that, because that can be an individual choice as to what kind of car you drive and your lifestyle in relation to energy use. But that's not going to move the needle in other countries unless there's similar sentiments there. So it becomes an international conversation. And ultimately, the renewables should be empowering all over the world. People don't want to rely on petrostates for their well-being. So renewables provide a path to self-reliance and independence. So they're a source of freedom.
Well, let's hope.
That the world should embrace.
Renewables are definitely part of it. There were always the three things. There was conservation, renewables, and I forget what the other one was. Recycling. That's what it was. The 3 R's. So I'm looking forward to finding how we can A, get acceptance that this is happening, B, get pathways, get directions that people can take that they feel like they're making progress with, rather than compromising their lifestyle in order to meet some unreachable goal because nobody else is following me. Where is the hope? I know you're throwing the hopeless at me, and I'm trying to find the hope. Art, you want to give me some ideas?
Yes, well, we're living in a hopeless generation right now, but there's hope out there. There are some models, I think, for success. But whether or not we band together as a global community to address this problem is unclear because of selfishness of the individual, selfishness of the corporation, the ability of corporations to control people with false media, misleading reports, and things like that. But Ralph and I are scientists, and in sort of an analogy of a newspaper, we're the reporters, right? We're just saying what's happening, and we can explain what's happening through a variety of things, through making the direct observations, through theory, and through running models to show how things actually are functioning. And we report that, right? Then there's sort of the editorial part of the newspaper analogy, right? We don't necessarily write the editorials ourselves, but there are some people who are really strong advocates for changing behavior in our society. And, we do that a little bit, like Ralph was pointing out, when people ask that question, we try to come up with positive news in a gloomy environment. But it's hard for us because that's not what we spend all our time doing. We don't, at least I don't go read every possible new technology and master the understanding of that stuff, right? But there are people out there who are doing that. And all of a sudden, innovation hits and things change. We, hopefully in the coming decades, fusion will start working for energy, and we can switch that way. But of course, the whole infrastructure of that will probably take decades to build anyway. But the idea of using wind power and hydroelectric power and things like that, that's important, as well as solar, right? So we need the infrastructure, and we need leaders to take us there.
Yeah, well, and
let's work together to make them do that.
You are reporting, and there's the real connection that you alluded to, Art, is that where is the editorial stance that is spreading the news, and how is that news being spread in a way that people can respond to it rather than not? I want to take the other side of it, in that academic freedom is a question right now, especially when it comes to these types of debates. Do you feel like your research is being unfettered in that regard, or is it being directed or managed in some way? Ralph, I'll ask you first.
The answer is no. Despite there is a pivot that's gone on in the last 10 years towards philanthropic organizations carrying a larger fraction of the support for the relevant science here. And in a sense, they might have an agenda that is less in tune with the public interest because they're not a government and they might have singular interests. And to the extent I've been the beneficiary of that kind of funding, I have, however, not felt that they were asking me to deliver on a particular message or so forth. So even though that pivot has happened, the private money that's come to play so far is pretty, you have to compete for it, but at that point, you're pretty much allowed to do and say what you want. So I don't feel it, but it is a concern if the government steps out in too big a way, and that there's the money. If you've got to go to Elon Musk for support for your funding, that's not a great thing at this point, because he's got various agendas and singular viewpoints, and so yeah. We're sort of moving back to a gilded age where a small number of very wealthy people are controlling the shots rather than the public fund through the government, and that's another troubling trend right now. But so far, it hasn't trickled down to big impacts that I've seen. I mean, in terms of ability to control the message. I mean, we still feel free to say what we want.
I'll chime in on that too, just because, I don't feel any, personal abuse in terms of not being able to speak, or the stuff that we write into refereed papers and publish in journals, or the way that we execute our research in real time. But the funding streams that come out of the federal government have been impacted by top-down forcing by the government saying, you can't have words like climate in your proposal anymore. You can't have words like diversity in your proposal. You can't have words like equity in your proposal. You can't have words like inclusion in your proposal, because I know he's
sure. I just want to agree with a key point you made, Art, and that is that to the extent that there's been a sort of a muzzling of our voices, it's coming more from the federal side than from the philanthropic side at this point. But as academics, we're still basically free to speak our mind, but it may affect our ability to raise money. So exactly. there is a bit of a conflict there. Let me try to make another somewhat nuanced point, so I might struggle with it. But science isn't just necessary to take action to mitigate harm; it's necessary to adapt. It's necessary for resilience, and so. I mean, the same science that builds the case for doing something about it is the science that helps us understand how bad it's going to be and get ready for it. So that perspective then gets paired with a head in the sand approach to the risk going forward. And that's super negative impact on society, way more than just not mitigating the problem. This is pretending nothing's happening and just rolling right off the cliff like in a joyride. That's no way to run a government. That's no way to run a society. But that's what we face right now is leadership that's got that kind of perspective. It's just ridiculous.
And the other part I wanted to come back on is that yes, your science is showing that we need to do something about climate change, but your science also helps us decide where and how to plant and grow food. Your science tells us where we should go fishing. Your science will tell us how much road salt we're going to need next year for the blizzard that we expect. Those are the kinds of things that people can grasp every day and understand that that what the same indicators that farmers use that your data is providing, that information is also telling us we need to adapt to climate change. And that's somewhere where I think we can get out of that polarization. Hey, look, we're growing too fast. We're heating up the world too fast, and we need to do something about it tomorrow or yesterday. Art, you were going to say something.
Well, now that you said that, I'm going to point out that when you study the climate system, there's a lot of extra benefits that come from it, like you just mentioned, like understanding, topics that are related to management issues, such as fisheries, water management, and things like that. The point I was going to make was that there is a little bit of light at the end of the tunnel that occurred to me just as we were talking. When I came into the field of oceanography and climate back in the 1980s, basically every PhD student worked on a very narrow topic, right? Everybody was focused on their science. They would write papers and they would go talk about it with other people who studied that same thing. And now almost everybody who comes in to do PhDs at Scripps has some altruistic goal attached to the idea of getting a PhD and doing research and then helping to make the world a better place. So to me, when I see students these days, virtually everybody that I talk to says, yeah, I want to help make things better. So to me, that's a little bit of light at the end of the tunnel that we're talking about right here, that the next generation of scientists may very well become more politically active and going to work in NGOs and things like that after they get their PhDs, or active in public speaking and carrying messages to the rest of society, how we need to change our ways. So,
do you see that trend, Ralph?
Very much so. I mean, I can connect it also with the process known as the Intergovernmental Panel on Climate Change, which writes reports on the state of the climate science every 5 or 7 years or so. The community came together on those. So there are massive authors coming together, massive numbers of scientists coming together to write these reports. But then when they're done, there's this expectation that we can all speak for the whole report rather than just the little slice of it that we put into it. So there was a burden to educate across disciplines that came through that process that was very healthy. The countries that lead in science, the world leaders, are countries that take on grand challenges. And they're not just thinking about, what can we do to boost economy in this area, that area. You bring in people, the best and the brightest want to work on the big challenges of their era. And a country that abandons grand challenges is going to abandon leadership. And climate change is one of those grand challenges. And it inspires people to come and work on big problems. And those people aren't just working on climate. The same people are working on weather forecasting. They're working on all sorts of other ideas that benefit society. But if you take away a grand challenge, the talent's going to flee to other countries. And the U.S. is going to really get punished for that, if that plays out.
Are we training climate scientists sufficiently and in sufficient numbers to help realize some of the goals that we've been talking about to reduce the curve?
I think so far the U.S. has done well. But I mean, you see it already. I mean, we were bringing in postdocs and graduate students from other countries in significant numbers, and these people would often stay here because of the opportunities that it presented, and that um, conduit of talent has slowed down a lot in the last year.
The funding streams that support PhD students in all aspects of Earth system science, which includes the climate system, the ocean, ice, and ecology and humanity, right? A lot of those funding streams are being, strangled, and it's delayed and, changed so that people can't extend offers to postdocs and visiting scientists and PhD students.
Well, and a lot of your work, Art, has been in training those students for tomorrow. In addition to the research that you do, you train the next generation, and you see that happening all the time. Look at the benefits of this country, and look at the benefits that the industrialized world has received through science, through the developments that we've come across, and how are we going to continue that progress in a way that doesn't kill this golden goose, this blue planet that we have? That stupid song, accent the positive, eliminate the negative, don't mess with Mr. In Between, comes to mind when we're talking about the world burning up. So I appreciate the things you do. I appreciate what energy you bring to it, and the fact that you get up every day and do it. And can you just leave me with, why do you get up every day and do this? I'll start with Ralph.
Well, I got into this business not because I wanted to save the world, because it looked like a fun problem. So I get up every day and I work on it because it's fun. I mean, it's challenging and it's depressing in ways when you think of the big picture, but the day-to-day is fun. I mean, it's fun to work on a big problem. It's fun to work on something that people notice about, care about, and it's got its ups and downs. It's got its challenges. There's still new frontiers, new things to measure, things that haven't been done before. There's a landscape of opportunity, and embracing that and enjoying the process. That's what gets me up, keeps me going.
And you, Art?
I feel the same way. I mean, I still pinch my butt every day when I'm walking along the beach in La Jolla thinking, I made a career in science, thinking for a living and trying to understand the oceans, the atmosphere, the ecology. And to work with scientists who are also doing the same thing. We just love discussing those things, trying to understand systems better. And I also, like you mentioned, I do take delight in mentoring the next generation of scientists and helping them find their career paths in all different directions, all different types of science. I've had PhD students doing things. It's incredible. And the other thing I really like doing is talking with people who genuinely want to know what's the situation. I mean, even those who are embedded in the media of climate denialism, and that might be somehow part of their belief system. Breaking those chains to misinformation is really nice to see happen when it does happen. And that I look forward to more conversations like that in the coming years.
Well, it is refreshing when the veil does come down and you see that spark of recognition. And that can come from just, having a cup of coffee with somebody, and sometimes it happens in a large room. Sometimes it happens, in passing. But the fact that it happens is the important part. And I'm glad you guys are getting up every morning and checking out those problems and enjoying the hell out of solving those problems that we face every day. So thank you very much.
Thank you, Jeff.
Thanks, Jeff.
On June the 4th, 1944, meteorologist Captain James Stagg convinced General Eisenhower to delay the scheduled D-Day landings 18 hours to the morning of June 6th, thereby averting a potential disaster on the beaches of Normandy due to heavy weather. In other words, a climate scientist was instrumental in the successful landing of Allied forces who went on to liberate Europe and vanquish Nazi Germany. Today's climate science offers benefits by providing similar warnings, but only if we heed them. Our thanks to Ralph and Art and the Scripps Oceanographic Institute at UC San Diego. You can learn more by visiting the Keeling Curve Foundation at www.keelingcurve.org. Production and editing services provided by Dudley Peacock of The Wave Podcasting and Pat Honstein. I'm Jeff Rollet. Are you a leader in your community? Or do you know a leader making the world a little bit better each day? We want to hear from you. Let us know by contacting us at whenpeoplelead.com. Thank you for listening, and don't forget to subscribe to When People Lead, wherever you get your podcasts. Like us, tell your friends, find the leader within.